to Frequency Matters, the RF and Microwave Update series. I'm Pat Hindle. I'm here with my co-host Gary LaRude. And today we're going to discuss the space market as it's been very active recently with the emergence of new space. Here to discuss this subject with us is Eric Olson, Mini-Circuit's Global Market Manager for Aerospace and Defense. Welcome, Eric.
Good morning.
So Eric, the space landscape has obviously evolved in the recent years with a lot of growth of the commercial launches and some of the private satellite services, in addition to the government missions. Can you tell us what are some of the differences you've observed in the traditional space applications versus new space?
Sure. You know, it's funny. I find it interesting how quickly the phrase new space has really embedded itself into our industry lexicon. And really, for all that is new, there's much that is not new. Space is still a difficult and unforgiving environment, and the challenges of developing, deploying, and operating payloads for long or even short duration missions still demands the highest attention to detail. Even still, the recent evolution of the industry can't be ignored. The commercialization of space is accelerating, and advances in technology are enabling higher reliability, smaller form factors, and exponentially greater capability. And I would say that, some of the notable differences we see today are in some sense, obvious. One example is the capability per unit volume of the payloads. From the large scale geosynchronous communication satellites or scientific satellites to the low Earth orbit nano and CubeSats, the systems are far more capable than systems from even just a decade earlier. And the deployments themselves are also of a hugely different scale. There were some visionaries back 30 years ago who conceived of these large constellations, and we're now seeing these come to fruition, and then some, really. SpaceX's Starlink, as far as I can tell, they lead the industry right now with over 1,600 operational satellites. And if approved by the ITU, they're headed for 30,000 satellites, which to me is just, unheard of. So I would say, really the pace of progress, the scale of the architectures, and the move to more commercially oriented deployments are the biggest differences we've seen.
So given these macro trends, how have you seen them flow down to the requirements for RF components?
Well, as I mentioned earlier, there are some obvious differences in the latest generation deployments. The satellite form factors are driving the innovation on many fronts: size, integration, power and spectral efficiency, and software-defined operation. And from the RF frame of reference, I guess the evolving applications are requiring higher frequency, broader bandwidths. They're also requiring more performance. Again, they're pushing the very last bit of capability out of these satellites. There's also, I think, because the spectrum is just getting tighter, more precision filtering and different approaches are really being driven. So, and these changes fall really nicely into Mini-Circuit's portfolio, I would say, given our design philosophy and our recent investments. Separate from the product electrical requirements, I think the differences in today's applications are driving less obvious requirements for components and subsystems. Traditional communications or the scientific payloads are living in a hellish radiation environment, subject to greater cosmic and solar particle events, and they're expected to operate over really long lifetimes. Conversely, the low Earth orbit systems are less exposed and have shorter mission lifetime expectations. So the reliability requirements are different, and in the case of the low Earth orbit systems, often much less demanding. In addition to the different operating environments, we also have that increasingly crowded spectrum, which I mentioned earlier, which is driving innovation in the radio architectures to allow these mega constellations to operate without interfering with the legacy systems or blinding some of the very sensitive scientific satellites that are out there.
So Eric, what is Mini-Circuits doing to address these wide variety of needs for different missions?
Yeah, so I would say it's not maybe as well known as we would like it, but Mini Circuits has been in this business for over 30 years. We've supported programs from NASA, NASA JPL, traditional defense, and most recently, the new crop of commercial aerospace constellation missions. And Mini Circuits supports these leading edge payloads and missions through a number of different ways. And we've evolved our model over the 30 years to keep pace with the rapid evolution of the ecosystem and the rapidly changing requirements that each of the systems is driving. What does it really mean to support this industry today? Well, I think first and foremost, whether we're talking about new space or old, supporting our customers means developing the highest performance RF components possible. I mean, and that's really the ante into the game. And to further differentiate, and more importantly, to really support the last detail of our customer requirements, who are developing today's systems and applications, really means for us to understand their systems, identifying and developing products to meet their electrical requirements, and being flexible in supporting their varied environmental screening requirements. And then again, this is where Mini Circuits excels. We have a strong applications team that has worked with the industry very closely for a very long time. I would say that we understand this market, and we understand that not every mission profile is the same. So while we're developing standardized process flows to be as efficient and timely as possible to support our customers' always shrinking timelines, we're also listening to our customers and working with them to assure that they've chosen the best product for the task, number one, and then to align our capability and the screening requirements to their mission in terms of the mission type and duration and other significant details.
So give us a sense of some of the specific products that you offer for space customers, and also what kind of screening can you provide?
Sure. Well, our approach is to work with our customers to take our existing COTS models and then screen them to their requirements, as opposed to having a portfolio of already screened models on the shelf. And this is really driven by our customers' often very unique requirements, which need some level of customization in the product or the screening process itself. So it's, we found that it's very difficult to just put a product out there to a customer and say, well, this is a space screened product, because space screening means different things to different people. So we're really open to talking with customers about most of our catalog offering. And what we found in those conversations is that they've been primarily gravitating to some of our key product lines, which are our LTCC, our core and wire, and our MMIC die products. Without sounding overly confident, I would say our space customers know Mini Circuits. They know us and our industry component heritage in terms of the product and technology breadth, the depth, and the quality we bring. So when talking about space payload programs, they are less focused on the products than on the process, because the mission really drives those exacting environmental requirements. And while we have been delivering upstream products for over 30 years, there are also lots of new players to the space payload market. So to help our experienced and also less experienced customers in navigating the screening process, we've recently created a landing page for our space upscreen process that describes in detail the processes we've created for our LTCC, our core and wire, our MMIC die, and also our non-hermetic products. Again, these represent the bulk of our customer requests, but we're open to talking with customers about any product to meet their specific requirements in terms of the product itself, any variant of that product, and then the screening process. And again, trying to stay as flexible as possible so that we can meet their individual requirements, again, driven by the mission type, the mission duration, and that the stress of the actual delivery.
Well, that seems like a very good strategy to try to make your entire catalog available and then provide the specific upscreening that's required for a specific program. So thank you, Eric, for joining us today to brief us on the new space market, the trends that you're seeing, and your strategy in this area.
Well, it's been a pleasure. Thank you for having me.
And we thank our viewers for watching Frequency Matters and urge you to follow videos.microwavejournal.com for more interesting interviews.